Finding the limit is the next part of recurrence relations, and you could see this by using your calculator if you type in a recurrence relation. Now, say for example the limit of the sequence is 25. If you kept pushing equals in your recurrence relation, what you'd maybe notice is that you would eventually begin to approach 25. You would maybe go 24, 24.5, 24.75, 24.9, 24.99, 24.999, etc. until eventually you reach to sort of 25 on that sequence. And basically it's all down to this value for a here that's before the un. So a recurrence relation will approach a limit if for the recurrence relation un plus 1 equals aun plus b, our a value is between -1 and 1. So a recurrence relation will not have a limit if it's not in this range. So if your a value was 2, it wouldn't have a limit. If your a value is -2, it wouldn't have a limit. But if it was anywhere between -1 and 1, you're going to have a limit. So if you look at example 1 here, find the limit of the following recurrence relation, un plus 1 equals 0.6 un plus 20, where our initial value is equal to 20. And we know that a equals 0.6. So our value before the un is 0.6. And since this is between -1 and 1, we can say that a limit exists. And the fact that I'm going to use to solve the limit question is the fact that when I reach my limit, my un and my un plus 1 will be the same value. Because if you reach your limit, it can't possibly change. So the next value is going to be the same as the previous value. So when I reach my limit, un, which is your current term, will be equal to the next term, which is equal to whatever value your limit is. So what we can do is we can take our recurrence relation un plus 1 equals 0.6 un plus 12, and we can say, well, when it reaches the limit, L, un plus 1 will equal un, so I can replace them both by L. So L equals 0.6 L plus 12. Now, I would at this point look at the decimal and think how you could make that a whole number, because I don't want to be doing subtractions with decimals. So what I can do in this case is I can say, well, if I multiply that expression there by 10, and remember to multiply every single term, that's going to eliminate my decimal here. So if I multiply by 10, well, L times 10 will be 10L. 0.6 L times 10 will be 6L. And then remember, 12 times 10 is 120. I can guarantee that that will be the mistake you'll make on these at first, because everybody always tends to forget that. You remember to multiply this by 10 as well, making it 120. It's so easy to forget to do that. So when you're multiplying by 10, make sure you multiply every single one of your 3 terms to get this line here. So 10L equals 6L plus 120. It then becomes just algebra work. Subtract 6L, 4L equals 120, and L equals 30. Now, you can do a check. So let's check and see, does this work? So if I substitute it into the recurrence relation, 0.6 times 30 plus 12 ends up giving me 30 still. So that means that it definitely is my limit, because when you put 30 in, the next value is also 30, and that will just keep continuing forever, basically. So what we can say is as n approaches infinity, so as you keep doing this process, the limit will approach 30. So the more you do this process, the closer it gets to 30, before eventually when it reaches 30, it can't move any further than that. So in this case, our limit we've worked out is 30. I'll take you through a second example, and hopefully that should help you really get a handle on this. So, example 2, given the recurrence relation un plus 1 equals 0.8 un plus 6, with our initial value equals to 19. Part A, which is a very, very common question in exams, is to state why the sequence generated has a limit. And then B, calculate the value of this limit. So our sentence for the first one will be, this sequence approaches a limit as n approaches infinity, since -1 is less than 0.8 is less than 1. So what this means is, as you do this recurrence relation more often, and you keep doing it and you keep doing it, eventually it will reach a limit value, and the reason is because 0.8 is between -1 and +1. Okay, because 0.8 is within that range, this sequence has a limit, and this will be the sentence that you're going to be writing for this part A every time. The only thing that will change is the 0.8. Whatever number they give you here will go in this category, but because it's between -1 and 1, that's why it's got a limit. So what we can do in B is we can take a recurrence relation, un plus 1 equals 0.8 un plus 6, and we're going to replace the un plus 1 and the un by L, because we know that eventually they're going to reach the same value, so we can say that L can replace the un plus 1 and the un. We then get to this point here, and we can multiply by 10, because that will get rid of the decimal here. So that'll be L times 10 is 10L, 0.8 times 10 is 8L, and 6 times 10 is 60, remembering to multiply every term there by 10. After you've done that, it becomes a case of doing algebra work, so take away 8L here, giving you 2L, and that equals 60, divide by 2, L equals 30. Do your quick check, substitute 30 in, 0.8 times 30 plus 6 gives you 30 still, so that is correct. So we can say that as n approaches infinity, the limit also approaches 30. So our limit in this example is going to be 30. Now it's a coincidence that it was the same value as the previous. It will not always be 30, it's just a coincidence with the two examples that we've done today. Now, this is the last note that you need to copy in. What I've got here is a quick slide with just a couple of points to take into consideration, and it's just about the limits. So some of these have a limit and some do not, so let's look through them. 1, un plus 1 equals 0.3 un plus 6. This will have a limit since 0.3 is between -1 and 1. So on a quick inspection of that, you should know that that's got a limit. The next one, un plus 1 equals 3 un plus 2, that does not have a limit since 3 is greater than 1. It's not within that range. Okay, you're really looking for 0 point something in reality. If you look at the next one, -2, again, that's not within the range. So it can't be a recurrence relation with a limit. So in example 3 here with -2 un subtract 1, that is not going to have a limit since -2 is less than -1 and it's not within the range. Now 4, un plus 1 equals -0.5. Now a lot of people might think that doesn't have a limit, but it does, because it is within the range of -1 and 1. Alright, so in this example, this one will have a limit as it is in that range. It can be a -0 point something, okay? So that's a key thing to consider. So try and familiarise yourself. When do you know it's got a limit? It's got a limit of 0 point something between -1 and 1. And anything without that is not going to have a limit. Now I've got 3 examples at the end of the PDF file for you to try. They are here. They are following the same approach as example 2. I'll post the solutions up to them this afternoon. Any questions, please ask in the Teams page.